In this lesson, we will combine all of our factoring techniques and completely factor a bunch of different kinds of polynomials. So let's look at this very first one. It's a binomial. It is of degree 4. Now, no matter what kind of binomial you are factoring, the first step is always the same. The first step is always to factor out the GCF. Now here, the GCF will be 5. So let's factor out a 5. And then now you have to look at this binomial and ask yourself, is this a difference of 2 squares, a difference of 2 cubes, or a sum of 2 cubes? Those are your only options when you have a binomial. A binomial, either it's a difference of 2 squares, a difference of 2 cubes, or a sum of 2 cubes. If the binomial does not fall underneath one of these categories, then the binomial is prime and will not factor. In this case, we have a difference, so it's either a difference of 2 squares or a difference of 2 cubes, and t to the 4th power minus 16 happens to be a difference of 2 squares, so we'll factor it as such. So we've identified it as a difference of 2 squares, okay? So remember, a difference of 2 squares will factor like this, right? A product of 2 binomials. One will be plus, the other one will be minus. And here, the first entries is going to be the term whose square gives you t to the 4th. What do you square in order to get t to the 4th? And that answer is t squared. If you square t squared, you get t to the 4th. And then if you square 4, you get 16. So that's what we do. Now notice this is a sum of 2 squares. A sum of 2 squares is prime. It'll never factor. Here is a difference of 2 perfect squares, so we must continue to factor. I'm going to copy down the first 2 factors because they are done. But this one here factors as a difference of 2 squares again. So it'll be plus in one and minus in the other. And you'd have to square t in order to get t squared. And you would have to square 2 in order to get 4. So that's how I factor that. So when you factor, ladies and gentlemen, make sure that you completely factor, okay? Completely factor. This is a difference, but neither of these are perfect squares, so we are completely done. All right, for the second polynomial, the first thing I notice is that there are 4 terms. Whenever I have 4 terms, I automatically think, let's factor by grouping. Before you factor by grouping, make sure you factor out the GCF, but in this particular case, the GCF is just 1, so we won't do that. But if the GCF were something other than 1, you want to make sure you do that first. All right, so here we go. I'm going to group my first 2 terms together. I always put a plus sign between my groups, and I'll group the next 2 terms together. The GCF in the first group is 2x squared, leaving me with x plus 5. And this binomial here, the GCF was just 1, okay? Now, there is an invisible 1 right here. If you would like to write it, that would be fine. You know what? I will. I'll put the 1, but usually I don't, okay? All right, so what's next is the factorization. So there's the common binomial factor of x plus 5 right here and right there, okay, that I'm factoring out, and then times what remains, which is 2x squared plus 1, okay? So times 2x squared plus 1. Let's make sure we are completely done. This is a sum, and the only way a binomial will factor when it's a sum is if it's a sum of 2 cubes, and neither of these are perfect cubes. This is a sum, and the same thing holds. This is not a sum of 2 cubes. So we are completely done factoring. So this is a complete factorization. Don't forget that you can always multiply. Some people call it foiling, right? You can always distribute, and you should always get the original polynomial back. All right, the next polynomial is a trinomial, all right? Again, I'm probably going to sound like a broken record, but don't forget that the first step is always to factor out the GCF. So the GCF here is going to be x cubed. Let's factor that out. It leaves you with x squared minus 2x minus 35. Whenever the leading coefficient is just 1, then all we're doing is finding factors of negative 35 that sum to negative 2. I'll say that again. Our goal is to find factors of negative 35 that sum to negative 2. And I think what would do it is negative 7 and a positive 5. After all, negative 7 times positive 5 is negative 35, and negative 7 plus 5 is negative 2. So this is the correct factorization, and we're already done. Remember that you can only think like this whenever the leading coefficient is 1. That is, whenever the leading coefficient is 1, it just boils down to factors of the constant that sum to the middle coefficient. Factors of the constant that sum to the middle coefficient. You can think like that whenever the leading coefficient is 1. All right, another trinomial here, but this time it's a quartic, degree 4, quartic trinomial. Notice the GCF is 1, so I will not be factoring out anything in the beginning. No GCF, okay? I mean, the GCF is 1, but we don't factor out the 1 because it doesn't change anything. All right, the leading coefficient is 1. The leading coefficient is 1. So I'm going to go ahead and jump straight into the factorization here. Now we know that whatever you put in the first, as the first term in each binomial must multiply to give you x to the fourth. So then I'm going to mess around with x squared and x squared. We know that x squared times x squared gives you x to the fourth. Now, because the leading coefficient is 1, I can think about factors of positive 25 that add to negative 10. Factors of positive 25 that add to negative 10. Now, the fact that this last term is positive tells me that the signs in here in my factorization will be the same. The middle coefficient is negative, so that must mean both of these factors must be negative, so that when you multiply a negative times another negative, you get a positive. But when you add a negative number to another negative number, you will remain negative. All right, so you should have 5 and 5, negative 5 and negative 5, right? Negative 5 times negative 5 is positive 25, and negative 5 plus negative 5 is negative 10. So that'll for sure do it. Now you cannot factor further because it looks like a difference of two squares, but it's not. This is a difference, this is a perfect square, but 5's messing it up. 5 is not a perfect square, so we can't factor it further. But I can write this in a neater way, in a condensed way, since it's a repeated factor. It's x squared minus 5 times itself. So then it'll be x squared minus 5 quantity squared. Okay? It's kind of a condensed way. It's a better way to write the factorization. All right, folks, we have a trinomial here. It looks pretty busy. 6x squared y to the fourth minus 21x cubed y to the fifth plus 32x squared y to the sixth. Now, what's our first step every single time? GCF. So let's think about the GCF. Everything is divisible. Let's see. The factors of 6 are only 2 and 3. So those are the only factors I need to check. Everything's not divisible by 2 because 21 is not divisible by 2. The other factor of 6 is 3. So let's check 3. This is divisible by 3. This is divisible by 3, but 32 is not. So can't do anything there with the coefficients. Let's look at the variables. Everybody has an x and everybody has a y. The best we can do as far as the GCF is concerned with respect to the variables, we can factor out an x squared. Every single term has at least x squared. And we can factor out y to the fourth, because every single term has at least y to the fourth. So let me go ahead and factor that out. X squared y to the fourth is the GCF. That will leave you with 6 minus 21xy plus 32y squared. Now I notice that this is kind of out of order, the resulting polynomial inside. It should be 32y squared first, and then minus 21xy, and then maybe plus 6. Okay, let's do it that way. Now in here, this will not factor further for us. No matter what you try, and you can try different ways to factor this, but it will not factor for you. So we're done. All right, we're jumping to example 7 here. And the first thing that I notice, I don't know about you, 4 terms all together. So I'm thinking factoring by grouping, okay? Factoring by grouping. The GCF, let's see here. Does everybody have a P? No, these last 2 terms don't have a P. Does everybody have an X? No, this term and this term don't have an X. Everybody does not have a Y. This term doesn't have a Y. Not everything has a Q. Okay, so the GCF is just 1. All right, let's try grouping these. So PX plus PY, and then plus QX plus QY. That's usually how I group my terms. I'm factoring out a P here, leaving me with X plus Y. I'm factoring out a Q here, leaving me with X plus Y. So I guess the final factorization would be X plus Y times P plus Q. Okay, that would be the final factorization here. All right, good deal. Let's move forward. All right, for this trinomial, to get us started, let's think about the GCF. The GCF here will just be 1, so we will not factor that 1 out, okay? So, because the leading coefficient is not 1, I taught us how to do the AC method. A times C, in this case, would be 25 times 4, which is 100. So you and I want to find factors of 100 that sum to 20. Factors of 100 that sum to 20. I believe that would be 10 and 10, wouldn't it? 10 times 10 is 100, but 10 plus 10 is 20. So what I'm going to do is I'm going to split this middle term into 2 terms whose coefficients are 10 and 10. All right, so what we're going to do is 25x squared plus, now watch this, 10, don't forget the variable part stays the same, xy, plus, and then another 10 xy, don't forget the variable part, and then bring down the plus 4y squared. And now we can factor by grouping. Okay, so notice that this term here, 20xy, split into these 2 terms. Okay, all right, now we'll just factor by grouping. We can do 25x squared plus 10xy in the same group, of course, and then plus 10xy plus y squared, or 4y squared, excuse me, in the other group. Okay, now factor out the GCF from each of these groups. The GCF in the first group is 5x, leaving you with 5x plus 2y. And the GCF over here will be 2y, leaving you with 5x plus 2y. Now, I know we're on the right track because I have a common binomial factor. That leaves us with 5x plus 2y, which is the common binomial factor, times what remains, which is 5x plus 2y. So I am done factoring. Now, because this is a repeated factor, I can write it as 5x plus 2y quantity squared because it's repeated twice. Okay, so this is the complete factorization for this polynomial. Because this trinomial factors as the square of a binomial, we call this a perfect square trinomial. Good job, everybody. Okay, here's a trinomial whose leading coefficient is 1. Oops, sorry about that. Whose leading coefficient is 1. Okay, I would invite you actually to try to factor this on your own. So I invite you to pause the video here and give it a shot, and then I'll catch up to you. All right, so go ahead and pause the video now. All right, so I noticed that the GCF is 1, so I'm just going to jump straight into this factorization. Because the leading term is p squared q squared, I'm going to put pq here and pq here. That way when I multiply both of these together, I get p squared q squared. Now, because the leading coefficient is 1, all I have to think about is factors of positive 12 that add to 7. 4 and 3 would work. 4 and 3. 4 times 3 is 12, and 4 plus 3 is 7. So this is actually the factorization for this trinomial. Again, don't forget that you can check if you're not confident, or if you just want to be really thorough, you can distribute, and I invite you to do so. And if you distribute and combine like terms, you will get the original polynomial back. Good job, you guys. All right, the next polynomial is a trinomial. Let's think about GCF. What's the GCF? If you thought 4, then you are correct. So let's go ahead and factor out of 4. That would leave you with 2x to the 4th power minus 5x squared y, and then minus 3y squared. Okay? Now notice that the leading coefficient is not 1. Therefore, I'm going to try to factor this by the AC method. Okay? The AC method. All right, in this case, a times c would be 2 times negative 3, which gives me negative 6, right? Now, don't forget, I'm not looking at the original polynomial anymore because it's been factored a little bit. So your leading coefficient, a, is 2, and then it's negative 3 as a constant, or not a constant, but the coefficient of your last term. All right, we have to find factors of negative 6 that add to negative 5. Factors of negative 6 that add to negative 5. So how about negative 6 and positive 1? Of course, when you multiply these two, you get negative 6. And when you add them, you get negative 5. So I'm going to split this middle term into two terms whose coefficients are negative 6 and 1, and the variable part stays the same. So don't forget the 4 out there, and then 2x to the 4th power, and then minus, we're going to have a minus 6x squared y, right, plus 1x squared y. You don't really need to write the 1 there, but I did. And then minus 3y squared. I'll close the parentheses here. So again, please notice that this term split into these two terms here. Okay? Now what we can do is just factor by grouping. So I'm going to invite you to go ahead and pause the video, the lesson here, and why don't you try to finish this problem on your own. All right, I hope you did well. I'm not done here. I just put the first two terms in a group and the second two terms in a group. Don't forget you have a 4 on the outside. Also, please don't forget that you need some kind of additional grouping symbol. It doesn't have to be brackets. It can be another set of parentheses, but you do need them. All right, the GCF in the first group, from the way I grouped it, is 2x squared, leaving me with x squared minus 3y. And then the GCF here would be a y, just y, and leaving you with x squared minus 3y. Okay, notice that we have a common binomial factor of x squared minus 3y. So then our final factorization, I believe, is 4 times x squared minus 3y times 2x squared. This is what remains, 2x squared plus y. So there's the complete factorization for this polynomial. All right, good job. I hope you guys are doing well. Let's do a couple more. All right, everybody, we have a binomial. Now remember, the binomial, even if it's a binomial, you always think about GCF. But in this case, the GCF is just 1. So let's go ahead and move on. Remember that you have 3 different options when it comes to factoring a binomial. It could either be a difference of 2 squares, right? Or it could be a difference of 2 cubes. or it can be a sum of two cubes. Okay, those are your three options. I don't know if that's off the screen a little bit. Let me move it over. There. Those are your three options. Now, this is obviously not a sum, so that's out. Let's go ahead and just kind of, get that out of there, off the list. So it's either a difference of two squares or a difference of two cubes. 16 is not a perfect cube, so I'm going to go ahead and cross that out. Is it a difference of two squares? If it is not, then this polynomial is prime. It does not factor. But it is a difference of two squares. Both of these are perfect squares. So we're going to go ahead and factor it as such. So here we go. It's a product of two binomials. One of them has a plus, the other one has a minus. Now, what you write here and here is the term whose square gives you a to the fourth. A squared, right? If you square a squared, you will get a to the fourth. Now the question is, what do you square in order to get 16b to the fourth? Well, if you square 4b squared, you will get 16b to the fourth. That's a little sloppy there. All right, so 4b squared in both of these. Now you have to consider, can I still factor further? Well, first of all, this is a sum, and it's not a sum of two cubes, so you're done, right? It is a sum of two perfect squares. It is a sum of two perfect squares, but a sum of two squares does not factor. It's prime, so leave that alone. This, however, is a difference of two squares, so that will factor further. Go ahead and copy down the first factor. And then let's factor this one as a difference of two squares again. Remember, plus and then minus. You would have to square a in order to get a squared. And you would have to square 2b in order to get 4b squared. So that's how that works there. And notice that you're completely done at this point. This is the complete factorization for this binomial. Pretty cool. All right, this will be our last polynomial to factor. Let us go ahead and factor out the GCF. This is read as 40t cubed minus 5s cubed. I don't like using s's because sometimes they look like a 5. Go ahead and change that s to an x or y or any other letter you want. All right, the GCF here is 5, so let's go ahead and factor out the 5. That would leave you with 8t cubed minus s. Try to make my s look really like a, curly s there, so that doesn't look like a 5. Now, are we done or do we keep going? Well, this is a difference, and it's a binomial. So your options are difference of two squares or difference of two cubes. 8 is not a perfect square, but 8 is a perfect cube. It's 2 times 2 times 2. So we have a difference of two perfect cubes here, so we're going to factor it as such. So a binomial followed by a trinomial. Remember the acronym SOAP will help us get the correct signs. Now we went over this together. S stands for same sign, opposite sign, and then always positive. So same sign, right? Opposite sign, and then always positive. Now the term that goes first right here is the term whose third power gives you 8t cubed. What do you cube in order to get 8t cubed? You would have to cube 2t. If you cube 2, you get 8. If you cube t, you get t cubed. Now, what do you cube in order to get s cubed? Well, that one's easier. You just get s, right? S raised to the third power gives us s cubed. Now, this first term in the trinomial will be the square of 2t. So when you square 2t, you get 4t squared. The middle term will be the product of both of these. So 2t times s, so it'll be 2st. I'll put s first because, I don't know, alphabetical. The last term will be the square of your second term. So the square of s, so s squared. This is the complete factorization for this binomial. Don't forget you have a 5 out front, right? That's the GCF. All right, everybody, good job. So this was a mixed bag of polynomials here just to kind of get you really comfortable with factoring any kind of polynomial. All right, good work. I'll catch you soon.